Hello everyone, this is Dr. Aeronautics. This is me here, Dr. Aeronautics. Today is the big day. Shortly, we will board and pack the XR2 Ravenstar Saturn Skyhopper craft. By the time the video ends, we will have traveled to Saturn, dropped a probe into the atmosphere, skimmed the A and B rings, and landed beside a geyser on the snowball moon Enceladus, but the geyser itself won't be simulated. If my fuel calculations are correct to within 95%, and in the words of Jimmy Neutron, a 95 is still an A. So let's begin. We are just under 2.5 hours, about 2 hours and 26 minutes over the designed time of departure from the mission. So I'm just going to walk over here to the XR2 Ravenstar. That will allow me to take control of it. Right now it's not possible for me to take control of it because the ship needs someone aboard it in order for the control to work. At least remember the way that we set it up. And I'm going to walk over here at a nice walking speed, nothing insane, because I don't want to get my heart rate up this early on, okay? Now, this is a little bit tricky here. I have to get really close to the airlock, and when I say really close, I mean like under it to the point where I wouldn't normally be able to board, okay? So I'm going to just go right up into here, right there, and we're going to try to climb aboard by pressing E. Okay, that worked. So, for full realism, we would have just crawled up into this chamber here, and here is the interior of our craft. We're going to go into here, so now we've just transitioned into the main chamber, and next we're going to climb up into the cockpit here, and we're now in the right seat, so we need to switch over to the left seat for our commander position. Okay, this is our proper configuration right here. Unfortunately, the virtual cockpit does not interact, but this is exactly where we are. Ooh, oh my gosh! The rudder pedals are identical to the rudder pedals that I am using in front of me. That's incredible. Now, they're set to a slightly different setting, but that's really neat. So I feel like I have the right rudder pedals. Oh yeah! I have a joystick, and the reason I have a joystick is because the XR2 Ravenstar itself has a joystick. So I am all kitted out as much as I can be for this. So we're going to go ahead and activate our regular 2D panel here. Now, we need to start getting some numbers that I call in the beginning. So, let's see. In the beginning, there was the Saturn Skyhopper with a fuel mass of 4,766.6 kilograms. Well, actually, I had to add another 600 on, so it's 5,366.6 kilograms. That means 204 kilograms in the RCS tank. The next items we can't calculate just yet. Oh, but we can do oxygen. Oxygen mass 5,000 to 5,929.7. And our empty mass we'll do at the very end. We need the crew, the total mass, and the payload mass. And in order to do that, we need to get the payload on board. So the first thing I'm going to do is quick save already. And now we're going to go to my friend Galileo Galilei, and he is going to help us load up the cargo. So he's going to turn over to here, and the packing order matters. We want the probe, I believe it's last, because we want the cargo adapter pallet to deploy the probe first, so that we don't have lots of things going on. So Galileo's going to grab this life module by pressing G. There we go, and we've got it now, so we're going to move it a little bit closer to the cargo pallet here. And what I want actually is the control module. That I want to offload first. So we're going to put that closest to the center of mass of the ship. Okay. And then, let's see, the flag will be second. So we're going to move the flag right about here. And then we're going to grab the habitation life module right here. Again, by pressing G. We'll stick that right here. And we will grab the space probe last, which has a name. I think it's called Purple Horizon. And we'll drop that right here. The next thing we're going to do is take control of the UGCO payload adapter. And it's going to be C to grapple cargoes. So we should get the... Oh, there we go. We should get the control module first for C. All right, and that has... Yes, that has captured the control module. And next is the flag. C one more time, the life module. Good. And then lastly, Purple Horizons. And if I press Shift-C, that should deploy the last thing that I just attached. Oh, okay. It's exactly the opposite order. That is not what I wanted. Okay. Alright, quickly, Galileo. We only have 2.5 hours. Okay, he's moved the cargoes. We're ready to try again. C, 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 C. And now if I shift C... Okay, that's deployed the probe. That's what I wanted. Okay, that should work for us now. Alright, everybody on board. Galileo's going to hop on and join me in the ship. He'll be in the co-pilot seat. And he's probably going to show up as the woman Kara Miller, which is a little bit funny, but
too far from
I don't
airlock.
think there's a way around it. This is what I'm talking about, right? You got to be like right underneath of it right here in order for it to work. Okay, so he's boarded, and actually no, that seat's going to stay open. That's kind of nice. Keeping things as realistically as we can. Okay, Cassini. Very shortly we should be going through the Cassini Gap. Go ahead and get on board. Your time to go to Saturn has come. And press the E key. And lastly, Johannes Kepler. Go ahead and hop on board.
Too far from airlock.
Okay, we should have a crew mass now. It's 120 times 4. So it's going to be 480 kilograms. That should be good now. The next thing that we're going to do is go up into the cargo bay here. And I think we're going to begin the first checklist here. The ground cockpit startup. Yep. Okay, so we're going to check for the damaged systems first. 4, 5, 6, 7, 8. Nothing is damaged. Okay, so we're going to go back to this. We're going to test the warning lights. There's 3 panels of warning lights. We're going to test panel 1. That looked good. Test panel 2. That looks good. And test panel 3. That looks good. Okay, now we're going to power on the multifunctional displays. And I'm going to plan the trip. So I'm going to do another quick save here. And all I'm doing is a simple target to Enceladus. Or not Enceladus, sorry, Saturn itself. Because we want to visit the rings. So we're not going straight to Enceladus. Okay, that's showing intercept. Alright, so we're showing 15.7 kilometers per second. Now that includes the Earth ascent. So that's 8,100 plus 7 brings us to 15,100. Okay, so I just did some checking calculations just to make sure. It looks like it's going to be close because the relative inclination difference between, or I should say that the difference in the longitude of the ascending node for Earth and Saturn is kind of really badly positioned. So we should check it one more time once we get up there. If we find that it's going to cause too much fuel to be used, we're going to try to replan it and see if we can get away with a lower delta V. It might not be perfect, but it might be able to be fixed by a mid-course correction maneuver if we had to. Okay, so the next thing that I'm going to do is get the takeoff time. So we're going to do select, and we're going to look for aligned planes, and then we're going to do ELS, and we want the inclination values from transect, so that's 26.21, and the longitude of ascending node or land value 21.99. Okay, and what you'll find is we actually have a bad time right now. We are decreasing. The time to burn is when the DN and the AN get as close together as they are. So we're a little ways away from that being the case. So we're just going to sit and chill for the time being. Good. Looks like our calculations are still good. So we're going to move forward with the originally planned launch time of, and it would be later if this isn't correct, 22:31:00 UTC. Alright, so we're going to continue on with the checklist. We're going to let's get the rest of the stuff on board the ship, okay? So we're going to go to the payload camera view. And the bay is open. Here's the pallet. So in real life, a crane would come out of this hangar, grab the pallet, pick it up, and hold it over the bay and slowly lower it into the bay. But we have to simulate that by targeting here, selecting bay slot 2, and hitting grapple. And that will disappear and reappear in the cargo bay.
Payload latched in bay.
There we go. So it's now on board the XR2 Ravenstar, and at this point we can get a few more of our in the beginning numbers. Payload mass 7753 kilograms, and we should have the entire ship together now. So we're going to deselect, return to the upper panel view, and we're going to go down to, actually let's make sure we got everybody. We got Dr. Aeronautics, Galileo, Cassini, and Kepler. That's everybody. So I'm going to go down here and take a look now. So our total ship mass right now is 39,431 kilograms. And then I'm going to subtract out the fuel mass. So that would be 34,064. The total ship mass without fuel or RCS so that's going to be vessel mass minus the fuel mass minus the RCS mass. 33,860. And lastly, the empty mass. That's going to be the full vessel mass minus the fuel mass minus the RCS mass minus the oxygen mass minus the scramjet mass, which is 3351, and then minus what we think the mass of the probe is, 356, showing the empty weight is 24,224 kilograms. So let's make sure that our launch vessel mass is what it should be, 39,431. Yep, 39,431. So in either case, we've got everything that we need. Make sure our oxygen mass is correct. 5,929.7. That's correct. Crew mass of 480 kilograms. Payload mass, 7,753 kilograms. That's correct. And then RCS mass is correct. Fuel mass, 5,366.6 kilograms. And that's correct. So we have all of our in the beginning numbers. So at this point, we're going to start time warping. We are pretty much ready to taxi. And let's see, I wanted runway, I think it was 28 at Wallop's Flight Facility. That should be this one. So that's going to be about a 5-minute taxi, so let's go about half an hour before the anticipated departure time. That would be 2200 UTC. Okay, so we've time warped. It's now 22:14. I think the actual liftoff is going to be slightly different. But anyway, we're ready to start the taxi. So at this point, we've time skipped. We're going to turn the HUD on, surface, and red secondary HUD to 3. We've recorded the ship masses, so we're all set to go. Now we're going to configure our MFDs. We want one of these to say surface. So this one on the left is keeping track of our departure time. The one on the right is keeping track of our speed and everything. We're going to turn the tertiary HUD on, and there was a random alert. This, I guess, was just a glitch telling us that the bay tanks were empty. This probably happened when we loaded the cargo bay with cargo, just letting us know, hey, there's no fuel in there. We know about that. We've got plenty of fuel on board. Hopefully. We're going to turn the temperature display to degrees centigrade. We're going to fire up the APU, and we have to be really careful about APU usage because it's going to be a very strict commodity. So the cargo bays doors are open. We've grappled the cargo, so we've got a number of doors to close. Okay, going up to the payload camera view, and we're starting APU fuel after a quick save. Okay, APU is online. We're closing the bay doors. Okay, return to upper panel view. Inner airlock door close. Outer airlock door close. Closing the nose cone. Okay, good. Nose cone is closed. Cabin hatch we're going to leave open, and then nav, beacon, and strobe lights are all on now for taxi. And then AF control and RCS mode is desired. Well, actually, we need to leave that off because we're going to check one more number. Okay, it is now time to enter our very first numbers. Okay, taxi maneuver. Fuel before ignition. 4,766.6 kilograms. The mass of the ship before the taxi maneuver is 39,429.220 kilograms. I'm going to check that again. 4766.6 kilograms in the main. Actually, I should be adding RCS onto it. 39,429.220. So what I'm going to do is that plus 600, because we know that there's an extra 600. Okay. V1 is going to be 0. That's fine. It's not applicable. V2 will also be 0. So now all we need is the mass of the ship once we've completed taxi. Okay, here we go. APU fuel on. AF control on.
Pitch on.
External cooling off.
External cooling offline.
Alright, we should be ready for taxi now. First ignition. Whoops. Oh shoot, we're going a little bit too fast here. I wish the graphics were a little bit better. This is something that I could probably work on if I had enough time. But it's just one of those things that I wish I could do, but I'll probably never get the time to do. So one of the things we can do is go to the airspeed hold autopilot and hold 10 meter per second taxi and engage. That will moderate our speed for us. It's like a strobe show in the back. We seem to be rolling pretty well. I'm quite pleased with this. And I wonder if this is because I disabled VSync. Although I'm seeing a... yeah, that's a terrain glitch. Not used to seeing that. Alright, and we know if you look at the lower left MFD where you see relative and then down to rate, when that switches from negative to positive, that's how you know it's time to take off. Alright, we're going down to 5 meters per second now. We're going to have a pretty sharp turn here. And if you care, your velocity in miles per hour is on the tertiary blue and white MFD on the center right. Now, due to the criticality of this flight, and when it goes off, we're going to take the runway and we're going to sit on it for half an hour. I'm sorry, but we're going to Saturn. Where are you going? Alright, disabling the autopilot now. And we'll call it there.
Pitch off.
So we're going to turn the APU off for a little bit of time just to, again, save it as much as we can. You can see we've already used a significant fraction of it. So taxi has most certainly ended, which means now we need our vessel mass again. The mass here is going to be 39,418.476 kilograms. And we've got a number that shows us that we've used 99.8 meters per second. So we saved about 400. Now, we're talking taxi, okay? It's not that way all the time with taxi. So, and I'm actually surprised that our numbers here haven't started to show up under the actual rate. So let me go ahead and prepare the ship for takeoff. And, well, actually there's nothing else to do until we get into the last few seconds. Let's turn the external cooling on again.
Hatch open. External cooling online.
You know, maybe it will be at 2230. We're actually very closely nearing takeoff. So I'm going to switch these MFDs around here. We're going to zoom all the way in here and bring up the aligned planes. And now if I go to Transx, that'll tell me which direction we need to take off. So far it's about 80 degrees. But that might change a little bit. We're getting really close. 92. Yeah, when that hits 90, it's going to be a takeoff. Which means we now need the next numbers, right? So the fuel before 4760.1, fuel before ascent, and we need the total mass of the ship 39,418.476. V1 is going to be 0. We don't know what V2 is going to be, but we'll find out when we get there. Okay, we're now down to 92 degrees from node. And once we hit 90 for AN over here on the left, or sorry, the right, aligned plane relative, AN says 90 and DN says 270, we take off. So we have about 140 over 2. We have just over 1 minute to go. All right, at this point, I'm going to execute the remainder of the checklist. APU on, cargo doors closed. Actually, I should be using this. Cargo door closed, inner outer airlock doors closed, nose cone closed, cabin hatch closed. Fuel checked and set. Nav, beacon, and strobe on. AF control surfaces on.
Pitch on.
External cooling off and observe life support activation.
Using onboard O2.
Okay, clock is ticking on the O2. We're good to go. We've taxied. We're going to set pitch trim. Done. End of checklist. Wait for takeoff time and apply full power. But we also need our final direction here from Transx. Yeah, that's settled on 79 degrees. Takeoff heading 79 degrees. Okay, here we go. That's close enough. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, now. Full power.
Knots.
Rotate 10 degrees at 143 meters per second.
V1. Lift off.
Gear up. Reduced to 60% power. Gear is up.
Gear up and lock.
Turning to target heading of 78 degrees. Full power, pitching up to 50 degrees. We're going to aim to be level at 27 kilometers. I've also disabled the sonic boom because, like I said, that's not realistic. The only thing that would happen is the vertical speed would go super high and super low and then look normal. Let's see, we're up at 20,000 meters. I thought it used to show feet.
Mach 2.
Something must be going on. Anyway, we're getting close to our level altitude here. It's supposed to... Oh, there we go. 80,000 feet right now. Okay, Mach 3, scram door open. We're not there yet. Okay, we're at 95,000 feet.
Mach 3.
There's Mach 3, scram door open. Main engine cutoff, full scram jets. Okay, it's just letting us know that the bay tank is empty again. I don't know why it's doing that. And we're just going to sit here for a little bit, wait for our engines to catch, then the ascent rate will be 100 meters per second. And I'm also keeping an eye on our relative inclination here, keeping that close to zero, because we don't, the rate close to zero. Alright, so we're pretty much level here, slightly descending at 100,000 feet. And if you take a look at the lower left here, the scram, you'll see that this number on the left here will come down, meaning that we're being more efficient, and the number on the right, flow, will go up. Okay, we're starting to ascend now.
Mach 5. Mach 6. Mach 7. Mach 8.
Secondary HUD ascent.
Mach 9. Mach 16. 17. Warning, scram fuel low.
And we're just going to let this burn all the way out because it's useless to us once we get out of Earth's atmosphere.
Mach 18.
Alright, that was a little bit less than what I was hoping. This is the end of the scramjets.
Warning, scram fuel depleted.
Scram doors closed. Full power, pitch 10 degrees.
Mach 19. Mach 26.
$190, $200, $210, $220, $230, $240. Main engine cutoff. Secondary HUD 5. Temperatures are now up to 48. Radiator open. Let's check the dynamic pressure at 0. Okay, radiator open.
Mach 26.
Okay, let's confirm that the coolant temperature is decreasing. Good. Okay, we want display in degrees Kelvin at this point. Elevator trim center. AF control surfaces off.
Pitch off.
RCS rotation.
Rotation.
HUD orbit. HUD color green. Activate prograde autopilot. Ship stable, cancel autopilot. APU power down. Okay, before we do anything else, it is time to get our numbers. How did we do? We're at 76, 78 meters per second, and I know that's changing quickly, but that's just for reference. Final mass of the ship, 35,624.788 kilograms. No. Oh, wait a minute. Okay. God, that scared me. So it's the scramjets. The scramjets are a little bit confusing here. So I'm gonna have to add the mass of the scramjets in. I was gonna say that told us that we just did a delta V of 37 kilometers per second, but that still seems kind of high. Maybe not though, because the scramjets are not as efficient as the mains. The mass of the scramjets, and this is why we do in the beginnings. There we go, 3351. So if I add that, I now get an actual of 4,136 meters per second. Okay. And I'm going to have to figure out what's going on with my calculator. Or I shouldn't say the calculator. The graph is a bit wrong. It's showing incorrectly. So I need to fix that. Okay, I figured it out. So what had happened was I forgot to add the 600 kilograms that are in the RCS tank. I don't think I'm going to do this again because this is really confusing me. Now, in the future, when the Actually, we could do it right now. We could transfer the 600 kilograms out. I might just do that. That keeps things earlier or easier to add, so I don't do this again. But I'm gonna do it when we're in the deep freeze after leaving Earth, because I got to focus on other things right now. But you can see we're doing good. We're actually gaining on the red line, not losing to it, which is really good. That's what I want to see. The mission continues. Okay, we've now reached the end of the checklist, which means that the next thing is the low Earth orbit circularization burn. That's going to be a little ways from now. Where's the time? 500 seconds, so just over 8 minutes away. Let's see if there's anything else I can do in the meantime. Oh yeah, I can take a look at how much plane change we need to do, right? I was expecting 14.55 and we have 11.83. So already our plane change burn looks like it's good, or looks like we're going to have the right amount. I guess I should also check the LEO circularization to make sure that we're in the proper orbit that we're in. So we were targeting 63, yeah, we're a bit low, 63.78. So the LEO circularization burn is going to be probably high, but that's okay because it's only 148 meters per second. The plane change is the one that's really important, and that's 2,027 meters per second, and that's forecast to be low, which is good. Let's take a look at TransX and see what the damage is for the Saturn transfer injection. This is where we could really get stuck with it. If we luck out, then that means that we're going to get to Saturn at least. 8.343, and I was forecasting 8,100. That should be survivable, and it might be even, yes, it should be even low after we do our circularization. It should go down by about 150 to 8,200, and I had forecasted 8,100. I think we're going to Saturn. I think we are. It looks like I need to update aligned planes, so 26.61, 21.99. .61 21.99. So these should read the same. 12.14 degrees. 12.14 degrees. Okay. So because I can accept this burn, I'm not going to try to mess with it. I'm just going to leave it as is. That's totally fine. So we're going to go back to aligned planes. Okay, and we have a 12.14 relative inclination burn. We're actually... which do I do? We got 100 seconds. We got to do circularization. These two burns could happen very close together. And I'm trying to figure out if I have enough time to do them. No, I'm not going to have enough time. We're just going to do the circularization, and then we'll go around the other side, and the descending node will burn there. For plane change. Keep things in order, right? The way we plan. Okay, I'm expecting at most 200 meters per second to circularize. And our main engines, if you look at... Actually, it has to be this autopilot. 16.8. Means we need 12 seconds, so we want to burn when we're 6 seconds from apoapsis. We need our numbers. We're going to be 4935.2 at the beginning. Initial mass of the ship, 35,624.773. Okay, and then V1, we're going to try to get that a little bit later, but it is showing 7559 right now. We'll get V2 a little bit later. So now we do our burn in about 160 seconds. Okay, we're about 50 seconds away from the burn. And the way I like to do burns is a 4-second ramp up. So by the laws of calculus, we're going to be forming a triangle in area. So I start 2 seconds before, reach 50% power when the burn is supposed to start, and cut and reach full power 2 seconds after. So you'll hear me count 2, 1, 0, -1, -2 as we build up. But for this, because the numbers are so small, I'm just going to pick the numbers themselves. So we're going to start on 8, 12, 11, 10, 9, 8, 7, 6, 5, 4, and we're going to go until we see 241 plus 241. All right, 100, 200. That's it. That's close enough right there. Cancel the autopilot. And now it's time for our numbers. So now we're at 7766. So off the bat, not even by doing by field calculations, I'm showing that that was 207 meters per second. A little bit more than it needed to be, probably only 200, but it did significantly cause an overburn here, unfortunately. But that was due to our under ascent. So let's see what our mass final was, and we should come pretty close to that number here. So 207. Our final mass, 35,603.881 kilograms. We don't have to be that precise. Oh, that's showing even worse. That's showing 215 meters per second. Okay, so we lost some ground there, but that's why we have contingency. That was more than 5%, but it's a moving average. So our fuel now is sitting at 14.3 kilograms. So we'll stick that into the fuel before the next time, and now you can see we've leveled off a little bit here. Still have plenty of margin, way more margin than we did at the beginning of the mission. So we're doing good. Also, now would be a great time to quick save. And now we're going to start planning for our plane change burn. So we've got a positive inclination that we need to stamp out, and we'll be going on the descending node, which means we'll be burning orbit normal plus. So that's where we're going to be. And at this point, things are getting pretty, I shouldn't say pretty quiet, but they're not busy anymore. So we've got more breathing time. The way I'm going to do this is mainly stop the video unless there's something interesting, and we'll come back for the maneuvers. That will get us to Saturn in a reasonable amount of time. Okay, we're now back onto the day side of Earth, over some, looks like a desert. I'm not exactly sure where this is. We're about 100 seconds from the burn. My guess is we're about to go over the Pacific, so it's probably Australia. So we want orbit normal plus. We're going to expect to fire the engines at approximately 43 seconds from TN in the lower right MFD. I'm going to guess this is Queensland. We can cheat by activating planetarian mode, pressing F9. That looks like a Tukanuka. That sounds very Australian. Yep, Canberra, Brisbane, and Sydney. I'm going to say that we're over Queensland. I can also activate the map here. Right the dividing line between, I think that's New South Wales and Queensland. So Queensland will be to the north. Alright, just to make sure, we're showing 12.06 for the inclination, 12.06 for the inclination. We're looking good. I'm going to go back to aligned planes, and about 30 seconds from the burn. We're expecting to see the number at about 43 seconds out. So 45 I will call -2. Or 2, rather. Okay. And 3, 2... Alright, I messed that up. It did not appear when I thought it would. Forgot to get our numbers, that's not good. I'll just have to use the 35603.88 before. And 7775, that speed's not going to change, so we'll put 7775 for number 2. And now all we need is our final mass. So what we're doing now is we're angling we're changing the angle of our flight path to go towards Saturn, and then once we're lined up, then we just add a whole ton of speed and go flinging out towards it. So that's what we're doing is we're aiming. Ready was taking off. This is aim, and we're going to fire next. Okay, we're getting close. 1.8, 1.6. 1.4, 1.2, 1.0, 0.8, 0.6, 0.4, 0.2, and here we go. Cut off. Right there. Okay, before we do anything else, we need the final maneuver parameters here. 35,444.922, our current mass. Yes, that's showing we only used 1,639 meters per second, so it was an underburn of about 388 meters per second, so we significantly gained there. Our fuel now is at 4755.5 kilograms. So now if I take a look at the graph here, we're going down with it, but our margin increases. So we are going to Saturn, or at least we're going to burn out towards Saturn, I should say. Go ahead and quick save. The next thing that I need to do now is start preparing for our... Oh, that doesn't look right. Unless, maybe the view is a little bit wonky here. That's not what's... Oh, ecliptic. Focus is what we want. Ooh, that scared me. And now you can see our relative inclination is very low. And consulting my notes here, it says that a perfect ejection burn will have 0 relative inclination, 0 delta V, and 0 semi-major difference at burnout. So what's our semi-major difference? Alright, so now we need those numbers before the Saturn injection burn. But luckily enough, we have a begin burn counter here. So we're about 2,500 seconds away from that. We're going to skip around to where that is, and that is where all the magic happens to cause us to leave Earth. Oh, but before I do that, we need to plan the maneuver, right? Because I said that we have some numbers here to do. So, going to my calculator here, We want to go down to maneuver. Oh, burn vector. That's it right there. Okay, and our X is going to be 10,300 meters per second. Our Y is going to be 99.3, and our Z is going to be 5. Actually, we've taken care of that 5,162 already. So we're going to have a yaw of 0.552. Just make sure that the numbers are right. Okay, yeah. Make sure that you're using the right units. Alright, so the burn will occur at a yaw of about half a degree, which is going to be kind of hard to get accurate, so it's going to be really close to straight on. Okay, and remember we always burn on the night side of the Earth, so at this point I'm going to float around and we'll come back about 3 to 4 minutes before the burn starts. I could not resist that. We are going over the Pacific Northwest right now. You can see the Strait of Juan de Fuca, Puget Sound, Seattle, Tacoma, Everett, Mount Rainier, the Stevens Pass, which has appeared in other episodes, the Badlands, Wenatchee, Yakima Valley, Ellensburg, and pretty much all the North Cascades. And now we're going over one of my favorite bases, Glacier Park International. You can see the area where the Marias Pass is, Marias Pass, whatever, that I have also used in Train Simulator. Very, very, very fun. And now we're coming out over the Great Plains. Okay, we're now about 3.5 minutes from the burn. We're back on the night side of the Earth now. We went into the night side about 10 minutes ago. So we're going to turn prograde, and while we're assuming burn attitude, we're going to get our numbers. 4155.5. Yep, and then we'll get the mass initial down here at the bottom. Let's see, 35,444.7. So 4755.5, and then initial mass 35,444.776. Okay, and lastly V1 7722 meters per second. And this one's gonna go crazy high because this is a big burn. Okay, we're close to burn attitude now, so let's make it exact, right? We want 0.52 degrees of yaw right there. And unfortunately, there's no way. I really wish that the XR2 Raven Star you could program to hold a specific attitude in space inertially. You can't do that, which is really unfortunate. So we're stuck with this. The burn will begin in approximately 100 seconds. If I do the math here, we're expecting about 8167. Hey, that's only 67 meters per second off of my guess. That's pretty good. 8167 divided by, let's see, it's going to be actually a little bit less than this because we're going to burn so much fuel that our mass is going to change. But it's showing us about 17 meters per second. So this burn is going to last 480 seconds. If I'm doing the math right, that's 8 minutes. So it's quite a big one. In fact, it's almost as big as what it took to get into orbit around the Earth. So, oh, we're leaving our burn attitude. Let's get back into that. So I'm going to pause the video and stop it once we get to Geo, and then, well, I guess I'll stop it and I'll let you guys know when we hit Geo, and then when we hit the moon, and then where we start to break free of the Earth and start to change where our travel goes around the sun. Okay, burn is coming up. 22 seconds to go. Actually, 20 seconds to go, because we're going to start on 2. 10 seconds. 6, 5, 4, 3, 2, actually, hang on. 2, 1, 0, -1, -2. This is the Saturn transfer injection, the burn that will take us from the Earth area to Saturn, lasting approximately 8 minutes. Oh, now I'm seeing a semi-major difference. Okay, so I know what to do now. Basically, I hold somewhere between 0.52 and 1, because it's impossible to get right until our semi-major difference hits 0, and then when it does, then I turn back and go full prograde at that point, and the semi-major difference will tell us when we have a perfect burn. Okay, so until we reach Geo, which is 42,160 kilometers in, I think that's that's radius. So we'll go back to radius now. Until then. Okay, we've just hit 10 kilometers per second. And just about now we're coming up. Right now we just passed Geo for apoapsis. So next goal is the moon, and that should be pretty soon. Okay, 300, 400. We've now passed the moon, and here comes Earth escape. We are now Earth escape. Let's take a look and see how this is progressing now. So the inner red circle is the Earth's orbit around the sun. The green circle is our projected orbit if we cut the engines right now. The gold dashed circle is what I am aiming for this to look like. And the outer red circle is Saturn's orbit, and the red line, where the red radial line intersects the red circle, that's Saturn's current position. Still only halfway through the burn. See you guys when it starts looking bigger on stage 2. Okay, we've doubled our orbital speed that we were using to go around the Earth already. We are probably about as far out as Jupiter for apoapsis right now. Coming along pretty well. There is 1,200 meters per second left, and our semi-major difference is down to 5.5. Still using manual thruster activations to hold our attitude here for the burn. I'm happy to report that our pitch has stayed at 0 the whole time. So we'll come back when it's time for main engine cutoff. Okay, our line has reached the orbit of Saturn, and we're now in the final countdown. Here we go. 70, 60, 50, 40, 30, 20. Main engine cutoff. Just a little bit more. Okay, that's it. The burn is complete. Let's take a look at the damage. V2, 15,530 meters per second. I think there's a way to get the exact through these MFDs. Yeah, there is, but it's changing too fast anyway. 15,530, I think I said. Alright, our final mass at the burnout. 34,654.029, meaning we burned 8,263 meters per second. So this was a little bit of a overburn here. And our new mass that we have access to is 3,964.9. We're out of the 4,000s. And when you take a look at where we are, yes, we lost a little bit of our edge that we had, but we still have plenty left to continue the mission. So we are go for the mid-course correction maneuvers, and assuming that those don't F everything up, we're going to be getting into orbit around Saturn. Okay, we're above Africa right now. You can see Jupiter to the right side of the screen. We're going to go up to 10 times acceleration. Very shortly, the Sun should rise behind the Earth for the last time. After this will be an open sunlight as we travel between the planets. And I think I see Venus too. Yes, that's Venus. All right, we're going to go up to 100 now. And we'll be leaving our blue planet home behind for the outer solar system. Next task is mid-course correction 1, which will occur when we have left the gravitational influence of the Earth. 1,000 times. The other thing I should check on is the moon. The moon will not be a factor. In fact, we're further out then. Okay, going up to 10,000 times now. Okay, we got another one of those weird bay tank empty things. That scared the living daylights out of me. I don't want to be out here and hear that. And for the majority of the journey, it will be the sun getting smaller over time. Alright, so taking a look at the ejection plan here, we want this to stabilize before we do our mid-course correction maneuver. We're going to auto-reference the Sun, and we're going to target Saturn. So you can see we and Saturn are going to meet at that intersection crossing point right there. Okay, Earth and Moon have been reduced to dots. At this point, we can definitely plan our mid-course correction maneuver. So what we do is we do maneuver mode, change that to on, and I have a feeling it's going to be outward that we need to adjust here. Looks like my feeling is correct. There we go, we're now targeting a location inside the rings. Now we hit view, and now we've got a plan. So, let's get our numbers. Let's see, V1 is going to be... Oh, that's miles per hour. 1 miles per hour. Guess that's not going to work. Oh well. We'll use 39,970 for the speed. Our initial mass... Well, let's check the fuel. It should be... should say in the tanks 3364.9. Yes, that's correct. Okay, and then the mass of the ship is currently 34,646.656 kilograms. And that's all we need. So we factored 1,019 meters per second, and we're going to do 908. So that's a little bit less than what I was budgeting, which is good news. That's kind of how I have been doing it, is just adding in a little bit. In fact, I think I added like a 5% to this one. Maybe not. I don't know. It's irrelevant now. Alright, so I'm going to slew to burn attitude. And the way this works now is I just look at that X, and when the X comes onto the screen, I start going towards the X, and it's a logarithmic scale, which means it's going to be impossible to get right onto the X, even with my knowledgeable thruster control wall. Alright, starting to come on. There we go, and right there. So, getting close to the pitch. Right there. So we'll kill rotation, and we're going to pitch down. Should be about 5 degrees or so. Okay, right there, we have everything we need. I'm going to go ahead and quick save. And 3, 2, 1, fire. Okay, that's it. So now we take a look at what our handiwork has done. Maneuver mode off. And we're showing that we're going into Saturn, which is exactly what I wanted. Okay, we're now at 39,980 meters per second. Almost all of that was outward. And final mass 34,560.749. That means we used 909 meters per second. That's the exact number. For MCC2, we're predicting a total mass of 3,879 kilograms. And since we're at a point zero, let's do our transfer at this point. Take a look at our graph here. We're doing good. We're keeping pace. We gained back just a little bit. All right, so the way we do this is I'm going to write down the numbers. This will be in the scratch zone because these are important numbers. We can't lose them. So fuel before transfer and RCS before transfer. 803.6, 3279.0. And now I'm going to do fuel after transfer, RCS after transfer, and I'm going to do 3,200 plus 600, and on the RCS tank minus 600. So we should get 203.6 and 3879. Here we go, crossfeed main.
Crossfeed main. Crossfeed, 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 off.
That's 0.1 kilograms off. I think I can live with that. $599.9 was actually transferred. Actually, no. 600.1. So just a little bit too much. Okay, the numbers are showing good, and if we have to touch the crossfeed again, we're in big trouble. Okay, so at this point, we're going to move to our secure configuration checklist, because we're going to be powering down for years. Tertiary HUD off, secondary HUD off, main HUD off, radiator check open or deployed. Yes, that's deployed. Nav beacon and strobes off. RCS mode off.
Off.
Hover and retro doors check closed, 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 and check oxygen. We have 6,398 days of oxygen. 6,398 divided by 365 gives us 17 and a half years, and we are planning a 14-year mission. We're go to continue. So at this point, I will continue moving the ship along, and when I feel that it's time that we do our mid-course correction maneuver too, we will do so. Until then. Okay, so it's been about a year and a half. You can see how much smaller the sun looks on the left, and our orbit has finally decayed to the point where we need to repair it. There is one planet visible in the inner solar system, Earth. It is right there. A pale blue dot at the tip of that pointer. Normally we would be able to see Venus, but I think we're probably looking at the night side, so it's dimmer. Earth is on the far side of the sun, so it's more lit up. Over on the right side of the screen right here is Jupiter. And we're actually about as far out as Jupiter right now. And let's see, Saturn should be on this side. We've never seen Saturn so far this episode, so let's fix that. There's Saturn right there. Not looking much bigger at all. Alright, so it's the same deal. We're going to go to maneuver mode, turn that on. And probably what's going to fix it the most is the outward velocity. Now we can start to look at our inclination here, 23 degrees. That's pretty good. Let's see what happens when we bring it down a little bit. Inclination still 23 degrees. That's pretty low. We'll have to fix it later, but that's actually a pretty good bargain. So I want to go on that trajectory. So we're going to go to view. Wait a minute. Oh, that's why. Go back here to view twice. There's our new vector. It's just an outward burn. But anyway, we're going to run our maneuver checklist now. So check throttles are off. They are off. And hover is off. Retro is on. Good. Hover and retro doors as desired. We're not going to use them. They'll stay closed. RCS mode rotation.
Rotation.
Lights as desired. We're in the middle of interplanetary space. I don't need them. HUD on. Secondary and tertiary HUDs on. Okay. And now we're ready to slew. Check that we're at 1x. We are. Okay. There is a possibility that we might not have to do a third mid-course correction. 10 Hygeia. I think that's... No, I think that might be a Centaur. I'm intrigued now. What is 10 Hygeia? Alright, so I'm going to look into the object info, which unfortunately you're not going to be able to see, but if I go into... There it is. It's at 400... Okay, it's a main belt asteroid with a radius of 215 kilometers. Okay, now I remember. It's the 10th largest main belt asteroid, I believe, that exists. Or the 10th discovered. One of the two. I think Pallas is bigger, or sorry, smaller than Vesta, and Vesta's 3. So it's probably a time thing. Actually, you know what? We need to auto-reference this thing. We don't want the HUD selecting Hygeia, although it's 4. Oh, that's 4. It's 3 AUs away. It's no problem. HUD. There we go. Ah, and of course, right? I said outward. That should be right there. Okay, our before maneuver numbers. Okay, real quick check. Our fuel initial is going to be 3879.1. I'm going to leave it as 3879 to not confuse things. Initial mass of the ship, 34,017.809 kilograms. V1, 12,660. So we've slowed down by more than 3 times. Now we're going to do our burn. And I'm going to do it at a reduced throttle because there's no reason to do it at full throttle. Okay, main engine cutoff. V2, 12,660. So it didn't change more than 10 meters per second forward or backward, and it shouldn't because we're doing outward. Let's see what we get. 215. That's going to have us impact Saturn at a good attitude for the probe at 24 degrees of inclination. We're going to have to fix the inclination, but it's pretty close to what I need. So I'm pretty happy about that. Okay, our final mass, 34,014.385. And that tells us that we've burned 37 meters per second. That means we've saved about 300 meters per second. Wow, that's good. Okay, so our new fuel load is 3875.7 kilograms. And let's take a look at... okay, I have another weird bugging thing. It's probably picking up on some values as 0. So let me move those out of the way. Hopefully we'll go back to the divide by 0. Okay, yeah, that has fixed it. Looking good. We're flatlining and the red line is decreasing. That's what I like to see. We're good to continue to MCC3. Oh, but first we need to undo the maneuver checklist. Go to secure configuration. Tertiary HUD off, secondary HUD off, check radiator deploy, good. Nav beacon and strobe off, RCS mode off.
Off.
Hover and retro doors check closed. Hover closed, retro doors are both closed, and check O2. We have 5,812 days remaining. Which is 16 years. Just less than 16 years. Not anywhere near than half our time. Very good. So quick save, and I'll see you guys when it's time to do MCC3, or if we decide that it's not needed, I will show you how we're going to adjust the arrival at Saturn. Until then. Okay guys, it's official. We're getting really close, and we are pegged at Saturn. So at this point, we're going to waive mid-course correction maneuver number 3. So we'll go to our spreadsheet, And the way we're going to do this is by adjusting our mass initial to what it is right now. 33,738.616. Whoops. 933. Read the wrong numbers there. The current speed, which is now 8558. P2, 8558. And the end mass will be exactly the same. 33,738.933. So we get a value of 0, which is obvious. We didn't expend any fuel. 3875.7. And if we look up, we should see, yes, we are completely flatlined, gaining even more distance. Alright, next step is the arrival inclination adjustment, and that happens when Saturn starts to become gravitationally significant to us. Okay, we're running at about 100,000 times the normal rate. Encounter with Saturn should happen in 3 minutes at this speed. And you'll notice, if you look at the orbit sun MFD in the lower left, you'll see now the G value is now 0.98. So what that means is there is another body that is affecting our gravity, and that would be Saturn. We're starting to get very close to it now. If you take a look at the lower right MFD, you'll still see the Christmas display of orbits, and the green line, which is us, and the red line are getting very close to intersecting. And very soon, that will change over from our en route planning stage to our encounter planning stage. And when that happens, we know that we're really close, and we can start assuming that the values that we see on the encounter will actually happen. So we're just waiting for that. In the meantime, I can actually slow down, and there's Uranus. Jupiter, Saturn's going to be up this way. Oh, Neptune too. Nice. And you can now see Titan. So the big, bright gold globe is Saturn, and just about a pointer's width away is a tiny orange dot. That's Titan. Alright, G value of now 0.96. We're getting really close to that flipping over. I think 0.95 is usually where we get the encounter pain. Alright, 0.95. I guess this is a different value of TransX, so it's a different build, so it's probably using a different value. We're starting to get really close. 93. Alright, let me see. I need to figure out how far away Saturn is at this point. So if I do... Actually, I still want orbit, but this time I want to reference Saturn. We're still 84 gigameters away. And you can see it's now 7% of the gravity. Okay, now 10% of the gravity. Alright, so at this point, I'm going to switch the orbit MFD to Saturn and leave it there, because this TransX thing is starting to bug me. I want it to switch over pretty soon, because Saturn is becoming gravitationally significant. Okay, there we go, encounter. So at this point, we'll just check a few things. Oh, well, the inclination creeped up to 45 degrees. I don't like that. But we should be able to deal with it. So at this point, we're going to start waking the craft up and preparing. So the first thing we're going to do, check the throttles are off. Yes. And yes, yes. Hover and retro doors, we'll leave those closed for the time being. RCS mode rotation.
Rotation.
Lights as desired. There's no reason to use lights. No one's living at Saturn. That didn't sound right. Nobody is at Saturn. I think that's the better way to say it. Okay. HUD on, and I want to move over. We're at 9.25 AUs. I want to move over to Saturn, so now I can see our distance from Saturn. And Saturn is a yellow planet, so when in the Saturn system, I use a blue HUD. That's one of the ways that I keep track of where I am. When I see blue, I know I'm way out there. Secondary HUD on, tertiary HUD on, and now we're just waiting down until we get to 7 gigameters. And you can see our inclination is still jumping around. Now, part of that's because we have barely any transverse velocity. We're going to dive steeply into Saturn, which we don't want, but that, as a result, that's going to cause the inclination to go nuts. So that will stabilize once we add a little bit of altitude. All right, now if you look in the lower left, that we have now gone green. Saturn is the gravitational progenitor, and any second now I'm going to go down to, all right, we're at 15 gigameters. I'm going to go down to 10,000 for safety, and we should start to see the Saturn system in all its glory. There's Iapetus and a whole bunch of other moons. Saturn is now a lot bigger than I thought it would be at this point. You can see the rings, Titan, Rhea, Dione, and let's see if we can see Enceladus. I don't know if we're going to be able to do that. Yeah, you can see Enceladus. It's blending in with Saturn right now, but it's going to be a bright white snowball. All this right here, this is the Saturn system, the mini solar system. All right, we're going to skip to 7 Gs now. Okay, here we are at 7 gigameters now. We're actually closer in than some of the outer moons at this point. Saturn is 91% of the gravitational influence, and if I go to align planes, you'll see we're actually at the descending node, which is a really good position to be in. That basically means that we should be able to get our inclination extremely low, even lower than what I had planned. So that's really, really good. I think that means it's summertime somewhere on Saturn. Anyway. So we want to, at this point, take our masses. Okay, current fuel level is at 3875.7. Our current mass is 33,230.284. V1 is 8371 now with respect to Saturn. Then we need V2 and mass final after burn completes. And this one's going to be a little bit tricky. So we're at a descending node. That means we want to burn orbit plus relative to Saturn. And we want an inclination as low as we can get it. And here we go. Alright, I'm going to take it really slow. I'm going to disable the autopilot because it actually can't keep up. 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, hopefully? Yes, 3. Okay, that's it right there. That's as much as we can do. But that's really good. Okay, so V2, 8372. Okay. Final mass, 33,224.053, which means this took only 69 meters per second. Because remember, we were doing a worst case scenario, and we were at 45 degrees inclination, so that's pretty good. Okay. Fuel before the next burn, the probe release maneuver, which we're about to do, is 3869.6 kilograms. So if I take a look here, yes, we are still flatlining. We are go to engage in probe release activities. So I'm going to quick save here. And what I want to do now is let's get back to prograde. I should note too that we used hardly any APU fuel to get out here, so what that means is if we have to leave, we'll probably factor in, what is it, 258, so we've used 10. Let's just say we have to leave if we're less than 20 APU fuel left. Okay. So I don't think that our orbit has particularly, actually it will stabilize once we add some room to it. So now I want to go to, we should be done with this for the time being. We'll have to go back to it. But I'm going to do orbit now. And the next thing I'm going to do is go down to full outward. And we're going to burn here, and we're going to change the distance to altitude, and we're going to burn until our altitude is showing about minus 200. Okay, we're at the burn attitude now. We need our numbers. $3869.6. Initial mass 33,223.947. V1 8372. Let's do our quick save here. And this is the probe release maneuver. Okay, there we go. So B2, 8373. Final mass, 33,212.431. Whoa, that was significantly more than I was expecting. So if I add this one and the last one, that gets to 195.6. And if I add these, it's 160. Okay, so my math is fundamentally wrong here. I'm going to add that as a note. Or is there a better location? Oh, yeah. Maybe we'll put it in the flight notes here. Oh, actionable items. There we go. Your math on the probe release maneuver was fundamentally wrong. And please don't highlight. Let's check our inclination to make sure that's still what I think it is. We want equator. Oh my gosh, I just made a huge mistake. So, Transx gives inclination in... Transx gives inclination in ecliptic, and we want equatorial. I hate that. It's so annoying. Alright, now I have to figure out how to fix this. It's showing that we're near the descending node. Okay, so in this case, we're going to have to say that the burn itself did not complete, the release maneuver did not complete, and we're going to have to continue burning. This one is going to be a mess, but hopefully we'll still maintain our height above the red line. Oh shoot, forgot about how quickly that adjusts. Yes, let's not be stupid. And I wanted the semi-lattice rectum to be where the where these guys were. Alright, that's it. So, 9.67 degrees. It is going to be as bad as I thought. Should have known. Alright, B2, 8373. Oh, but now our altitude is messed up again, which I have to fix it. Okay, here we go. This one should be pretty low. That was it. Okay, now we're done. 8373. And final mass 33,200.602. Now we're showing that we expended 258 for the arrival inclination adjustment combined. Alright, I'm going to put down in the actionable items. Remember, with 4 exclamation points. Inclination readouts on trans X and align planes are Ecliptic with 5 exclamation points. Because I'm so tired of that happening. If only we were going to Jupiter, we would have been forgiven for that. Okay, so that only cost us, let's see, we're at 326 and I budgeted 163. So that cost us about 200 meters per second. And in the grand scheme of things, we're talking 63,900 meters per second. It's not too bad. Taking a look, we still look very flatlined or go for the probe release activities. Okay, well that was a big mess. So this is it. Time to say goodbye to the probe. And when I say bye, I mean bye-bye, go on your journey, and then bye-bye a second time when it gets destroyed by the ever-increasing heat of Saturn's atmosphere. Okay, my checklist. Deployments. Activate prograde autopilot. And I want to do a probe release ephemeris. I want the classical orbital elements and time of release. For some reason, when the orbit is so narrow like this, the prograde autopilot has challenges keeping you level. I don't know what's up with that, but anyway. Alright, kill rotation. And we'll activate prograde autopilot. Quick save again. Okay, and now it's EVA to the cargo bay area. So do I have, I need, yes, my EVA checklist. APU on. Nose cone open. Open the inner airlock door. Enter the airlock. Close the inner door.
Translation.
Whoops.
Rotation.
Don't want to do that. Evacuating airlock.
Airlock depressurizing.
So my spacesuit had better be on right now.
Airlock pressure 0 psi.
Okay, that is it. Outer door open, Control O. Wow, what a view. And real quick, before we turn the APU off, we should also open the bay doors.
Information. APU fuel 90%.
APU off. And return to upper panel view, and for safety, lights on. Alright, Cassini, go to it. Let me save real quick.
Egress successful.
Select Cassini. And Cassini is now floating alone by Saturn.
Translation. Rotation.
Oh my gosh, that's the sun. Oh shoot, wrong number. That was literally wrong one.
Translation. Rotation.
Now would be a great time for a picture. Alt F1. I forgot my HUD actually works here. Alright, so I want to find the probe. And it's in the orange case. Yeah, that's it. So it's this one, right here. So I want to null my speed relative to the XR2 Raven Star as much as I can. And kill my rotation. And now we're going to deploy it. So we go back inside, and we need to get our orbital elements now. Let's go back to the Saturn Skyhopper. And we are... the orbital elements, this one. Negative 632.1 megameters. Okay, eccentricity 1.0924. Inclination 9.62. Right ascension to the ascending node, or land, 60.41. Argument of periapsis 2, 46.55. True anomaly 205.77. Time of release 2026 March 24th at 11. It's probably going to happen at 05:00. Okay, going back to the deployments checklist, I've EVA'd to the cargo area from the cargo adapter. Press 9 until, well, actually, no, that's not right. So I'm going to go to the, I'm waiting for it to get deployed here. So now I need to go to the cargo adapter. That's this one, UGCO payload adapter. And I should be able to just Shift C, and then I'm going to go back to the UMMU, press G to grapple, and then station keep. Okay, 3, 2, 1, release. There it goes. Picture, quick picture. Yeah. All right, Cassini. Actually, perfect. It's coming right towards him. We don't need to do anything. We just need to wait. Then we'll grapple. 3, 2, 1. Attempting grapple. We got it. Okay, and we're station kept right now. That's good. Okay, UMMU maneuver to off port side of XR2 Raven Star.
Rotation. Translation.
Oh, I need to keep an eye on my O2 level. 94%. I didn't even think about that. Let me add a note here to actionable items. UMMU, remember they have O2 durations. I don't think it's going to be a problem this flight, but you never know. UMMU maneuver probe to retrograde direction.
Rotation.
We're prograde, so all I need to do now is turn retrograde. That's going to be a rotation up, so pitch up. And here we go. Kill rotation. O2 level 92%, still doing good. Okay, we're going to quick save. Exit. And we're just going to confirm, go back to Saturn Skyhopper. Yes, we are on a re-entry trajectory. Okay. UMMU is maneuvered to the retrograde direction. Press G to release. Go to translation.
Translation.
And I'm going to press 1 a lot. Press U to activate. Go, 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 go. All right, it's booting. Too far from planet? Must be closer than 150,000 kilometers. Well, that's why we test these things. Hopefully I can command a reboot. We do not have the power to fix the orbit. We'll never make it back if we do. So the only thing that we can do is just leave the probe on its own and hope that it automatically boots once we're less than 150,000 kilometers. If it doesn't, we can try to force a reboot and see what happens. But we got to get back to the XR2. Temperature minus 270.2. Oh my gosh. It's got realistic temperature. Alright, there we go. Back in vessel reference mode. Well, unfortunately, that was not testable. I'm really bummed that the probe didn't say that you have to be closer than 150. Oh, 150,000 kilometers. Okay. So that's about half the distance of Enceladus. Once we get there, we're fine. Welcome back, Cassini. Ingress to the XR2 completed. Ingress checklist. MMU board command complete. AP1 Control A. Not Control C, Control A. Outer door closed, Control O. Airlock pressurized to atmosphere.
Airlock pressurizing. Airlock pressure 14.7 psi.
Inner door open. Welcome back. And we'll leave the nose cone open. No problem with that.
Translation.
Nope.
Rotation.
APU offline. And save. Okay, here we go. This is to save our skins now. We need to get out of here. So I'm expecting a maneuver of 2 meters per second. Let's see if we can cheat this one.
Translation.
Oh yeah, we could cheat. So we're going to maneuver until the periapsis altitude is 1433 kilometers. Cool. Our skins are saved. And that was nice. We didn't have to burn there. So, shoot, I forgot to get the numbers. Shouldn't matter though. We'll just assume the empty mass 32,838.973. Oh, whoops! I wanted main fuel 3846.6. 32,838.973. V1 8374, V2 8374, and mass final 32,838.97, and we should see 0. 32,838.97. 973. Okay. There we go. All right, now we're showing 0. Fuel before the next burn. This is important to write down. 3846.6. And save. All right, let's take a look at the graph. And you can see we are now at the precipice of our largest set of maneuvers in the entire mission. We're in a good position right now. Hopefully that remains the case. Okay, the next maneuver is the Big Kahuna, the Saturn orbit insertion. So we're going to go a little bit further. Actually, no. Let me figure out what our ring situation is. We need to avoid the rings. Okay, guys, so I looked into our ring encounter situation. So what I did was I went to the classical orbital elements to state vector calculator that I have, and I plugged in our current orbital elements from the orbit MFD. And what I did was I manipulated my true anomaly so that the Z altitude, so the height above Saturn's rings, or equator, since the rings are on the equator, basically shows as this value here, which we're more than a gigameter above. But when our true anomaly goes to 293.7, you'll see we're only about 2 kilometers above the rings at that point. So we can assume that that's close enough for the crossing. So all I did was just square root all of this, or I should say root some square this, and that gives me 86.8 megameters. Now, if I consult the information regarding Saturn's rings that I have from my Atlas of Saturnian satellites, what I'll find is that the C ring occupies everything from 73,200 to 92,200 kilometers. So we're going to go right through the C ring. Now, one of the things that Cassini did successfully was it targeted the Cassini division and flew through the Cassini division. It was pretty nerve-wracking. They closed the high gain antenna, but it survived just fine. So what's the C ring made out of? Well, if we look at the highlighted information here on Wikipedia, Voyager discovered that the gap itself, the Cassini division gap, is populated by ring material bearing much similarity to the C ring. So if Cassini can fly through it, so can we. We just probably want to shut the radiator, and we want to shut the nose cone for the ring crossing. But that should be it. Our trajectory is fine as is. Okay, a little bit of time has passed since we released the probe. It's probably way out here now. There it is. It's about 5.5 kilometers away from us right now. And it's going to go on its own separate trajectory differently than we are. So what I can do here is go to encounter. The next thing we need to do is calculate what our encounter berm is going to look like. And then on here, I can target the probe, and we'll keep an eye on what the probe is doing. So I've saved. We'll go back to our time acceleration. We have periapsis in 785,000 seconds, so I'll go to 1,000 times the normal rate here. Okay, here comes our Titan flyby. Very nice. Now it appears that I need to
Rotation. Translation.
adjust my altitude a little bit. Let's see, I wanted... $14.33. This is right on the edge of what we could do with our RCS. See, this is why we do these maneuvers further out, is because it becomes much more difficult to do them closer in. Okay. 1433. There we go. Now passing the zone of the innermost moons. Here's, actually, Enceladus is coming back again, and as is Mimas. So we can pay attention to these closer in moons that we will not be visiting. Maybe we'll get close enough to see Mimas. Now, Mimas looks like the Death Star. So, and Methone, that's going to be one of the smaller moons that's not round. Oh, yes, there we go. The ball of Mimas is resolved. Very nice. Okay, let's take a look at the probe. Oh, that's annoying. The name didn't stick. Doesn't seem to be doing anything. Okay, so apparently we can manually control the probe. We've just maneuvered it, and we went in the wrong direction, but that's totally all right. So we want to go in the retrograde direction. We can fix this. I'm getting excited. I had no idea that you could fly it manually. So I've taken control of the craft, and I'm going to fly it joystick, which is not the way NASA normally does it. And I want to, that added, so let's go ahead and flip around. We're going to turn retrograde now. And all we got to do is just get the altitude down to 0. Okay, it's working. Okay. Re-entry is guaranteed. Now we need to face the heat shield into the oncoming direction to Saturn. Good. Now I'm going to pitch down to -90 degrees. And hopefully we can spin this thing if it's on the right axis. So it's not pitch. Does roll work? No, roll doesn't work. Okay, how about yaw? Okay, yaw looks like it works. Alright, spin this thing up, and what that's going to do is improve the ability for this thing to face one direction for a very long period of time. The Galileo probe did the same thing. Unfortunately, it's going to be annoying for us, but we're all set. Let's go back to the Saturn Skyhopper. Okay, now having assured ourselves that the probe will descend to its death, sorry, but that's kind of why we're doing it, we can now focus on the rings. What I care about now is the time to node. So if I target Enceladus, that'll tell us about how long we have before we're going to be at the node. Okay, we're getting very close to the C ring now, but we need to get really, really, really close. So I need to. It's not telling me the time to node, which is kind of really annoying. We do latitude and longitude on Saturn. We know that when we've hit the equator, we'll be there. So we've still got some time. And you can see right here, the darker ring here, that's the A ring. The B ring is the slightly lighter one, and the really light one is the C ring. Now, that's the opposite color, but we're looking at opaqueness here. So the C ring looks light because it's backlit by Saturn. Remember what I said about the purple horizons? There you go. That's why I named the probe the Purple Horizons. Alright, at this point, I am going to prepare for the ring. So APU on, and we're going to close everything. Nose cone and bay doors close. Okay, we're closed up. And then lastly, the radiator. We can turn our lights off now. Okay, radiator's in, APU off, and we'll turn into the velocity vector.
Rotation.
To deflect as many impacts as possible. And that's it. Should be a couple more seconds now. That's it. And you can see it's much brighter now at the A ring. Get a few pictures there. That's our ring passage. And then, so we don't overheat, we're putting the radiator back out. And now we need to address the big arrival burn. Okay, so bad news. It looks like our burn is going to be a little bit bigger at 4647, so that's going to be another 200 meters per second more than this. That's why we have the contingency. That's all I can say. So now, if we go out to, I think it's maneuver timing. There we go. So our delta V, I think, is going to be 4647. The ship initial mass, right now, it is at 32,828 kilograms. The tank capacity, this is where I have to be careful. I think it's the full capacity, which is like 13396 or something. ISP... We need these numbers from here. And I also need the engine force. $384,000 newtons. It shows that we're going to start our burn 199 seconds from periapsis. It's going to be a 400-second burn. Let me just double check that, right? 4647. And right now we're showing that we can decelerate at 21-ish. I'm showing a 221-second burn. Something is not right. Well, you're never going to believe this. You know, all that amount of time that I spent trying to make sure that this was understood, that it was shown as one engine, that was wrong. Could you believe it? It's 604, 600 divided by 2. So it's really 302.3 kilonewtons. I don't know why I set the config file differently, but we have what we have. We can't change that. Alright, let's go back and fix this. So it's really 605,000. Now I'm saying a duration of burn of 252 seconds. So if I take the velocity, divide by the acceleration that I'm showing, 20.6, that shows a 225-second burn. That's close enough. So we're going to start the burn 126 seconds from periapsis. Okay, having that dang mass out of the way, the next step is to prepare the ship for that burn. Okay, so the current situation here is the probe is now lower than us. So it's a little bit of a scout. It's going to take a gander at the safety. I want to know what the atmospheric pressure is at our low pass, which is 1,000. Oh my gosh. That's not good.
Translation.
We got to fix that.
Rotation.
See, we went back down to 1,000 kilometers. I need 1,400 kilometers. That's a very serious problem. Okay, I need to get the times right now. I don't want to re-enter. 3846.6 and 32,828. Okay, this is happening right now. This is rather unfortunate that I'm doing it this way, but we're not going to survive if I don't. Okay, I can hear Saturn's atmosphere now. That's not a good sign. I'm going to close the radiator for safety here. Turn on the AF control services.
Pitch.
We can't pay attention to the probe right now. Okay, the probe just re-entered and we are captured. Okay, that's the most we can do right now. We're turning retrograde. We're going to fire the engines here. We're actually aero capturing. Here's the probe. Okay, Saturn Skyhopper is still moving. Probe is currently re-entering. Wow, look at that. Alright, we gotta get back to the Saturn Skyhopper. Okay, are we at minimum altitude yet? This is way lower than I expected. We're up to 180 degrees centigrade. This is way deeper than I ever wanted to go in the Saturnian atmosphere. In fact, we don't need this anymore. Look at that. Dynamic pressure 25 pascals. Let me see what I was targeting before. Alright, let's get back to the probe. Let's see what our current speed is here in this craft. It's 13 kilometers per second and decreasing. We're now up to about as high a pressure as the Earth's atmosphere at 80,000 feet. Oh shoot. Okay, have we had periapsis passage? Yes, we have. Okay, Saturn Skyhopper's going to survive. And our target altitude is actually coming up. Okay, so the probe is now deeper into the Saturnian atmosphere. It's now at about Earth 70,000 feet. The stars are actually starting to disappear a little bit because we're getting deeper into the atmosphere. Unfortunate that it's pitch black. Okay, we got to get back to the Saturn Skyhopper. Keep an eye on this thing. For Q equals 10, so I was targeting 10 pascals, and we got up to like 30 pascals. A lot scarier than I had desired. Okay, so the orbit that we want to get into is 238,400. So we're at 285. This is almost it. All right, here we go. 240. All right, that's it. You can still hear Saturn's atmosphere. Man, that was scary. We're okay to open up the. Yeah, we're at 140 centigrade. We're good until 350 with the radiator open. Let's get that back open. Yeah, the front of the ship became hot as an oven. We can take hotter than that, but when you're talking gas giants, it's very dangerous. All right, powering down the APU, and let's take a look at the probe. Okay, so the probe is currently experiencing about the same pressure that you would see in a typical airliner. It really bugs me that this is the night side, because you would have been able to see so much detail. There's nothing to see here. Well, in that case, let's go back to the Skyhopper. Alright, we need our ending numbers now. Okay, ending numbers are... Let's see, I didn't write the V1 down, but it was probably 36,596. V2, 32,450. And the current mass of the ship, 32,319.475. And we've got 3340.9 left in the tank. So, as expected, that was a hot mess. That was me not paying attention because I was excited about the probe. We took a 31% hit. All that nice extra space is gone. We're back to where we started. We can continue, but we better not make this mistake again. Okay, we're leaving the Saturnian atmosphere now, and it's going to be a long time until we get to the node, which is the Enceladus sync and plane change. So we're good to go for the time being. Let's go back to the probe. Okay, now we're up to 50 kilopascals. So this is about the pressure that you would feel at 18,000 feet. And I can't tell if we're below the cloud layer yet. It doesn't look like we are, because if we were, then the stars would be blocked out. Damn, that really stinks. Like, it's scenic here. I wanted you guys to be able to see stuff. Unfortunately, there's no way that we could have done this. I should have targeted the other side. I should have targeted the day side of Saturn. There's no way that we can release the probe and be on the day side, because then the inclination would be negative 180 degrees, which means that we can't go to any moons. Okay, now about the pressure of Earth around 10,000 feet. So you see how it's all dark now? We've just descended below the ammonium hydrosulfide cloud layer. That's the bright yellow gold part of Saturn. So, that will never see the light of day again. Now we can start looking at Enceladus. How is the periapsis altitude of Enceladus 180 and the apoapsis 180 and the semi-major axis 238.4? That's not physically possible. There's something wrong with the Enceladus model. And I mean simulation-wise. Enceladus is not being simulated properly. Okay, the probe is currently at 2.5 atmospheres of pressure on Saturn. The one thing we can do is after it, well, no, that's not realistic. We can't do that. Oh, but we could take a picture using the night vision camera, and the night vision camera won't work until a couple hours from now, because it takes a while to process on board my ship. Yes, we could do that. 3 atmospheres of pressure now. Ooh. There we go. Press K to enable automatic pilot. Ah, it's alive and booting. I wish I had known this earlier. This could have been a little bit more realistic. 4 atmospheres now. Oh, nice. It's gone still enough that you can actually hear the Saturnian atmosphere through the microphones of the probe. You're hearing the sounds of Saturn. Okay, so what's happened is the orbit was set to distance, so gave me altitude readout 235. I thought it was good. Then this confused me. Then I realized that no, that's set to radius. Enceladus is where it's supposed to be, and we are not. So we underdid the burn a little bit. So now we're going to have to straighten up this side here to repair it a little bit. And to do that, we're going to need to come up to the apogee and raise the perigee just a little bit, because I don't want to go down into the atmosphere again. So we'll have to figure out exactly what we want to do for that. Meanwhile, the probe has reached 5 atmospheres of pressure. It's now moving 105 meters per second. And we have gone back up out of the atmosphere of Saturn. There's now no detectable atmosphere. So that is all I want to do with the atmosphere of Saturn. So I think what I'm going to do next is adjust the periapsis to swing down to 5,000 kilometers. We'll go through the rings one more time, and that will allow us to target Enceladus on the top side. So if we're going to do it that way, then in that case, the Saturn capture burn, as bad as it is, already 30% overburn, is still not finished. So we're going to need to add a little bit more, but it's just a little bit, maybe another 100 or 200 meters per second, nothing crazy. Okay, the probe is now experiencing 6 atmospheres of pressure. So at our current altitude, we're now drifting down through the ammonium hydrosulfide clouds. These would be pink, but you can't see them on Saturn because it's colder. So the ammonia clouds basically coat all of Saturn. I think the idea is that on Jupiter, if the gases get lofted high enough, it'll get cold enough to form the yellow clouds. Okay, I think that was the heat shield just jettisoning. Engine braking. Well, good luck with that. Don't think that's going to work well. So, yeah, the deal is, on Jupiter, only the highest gas currents can cause those yellow clouds to form. Saturn is cold enough that they spawn everywhere on the planet. That's my guess. Or not my guess. That's what I think that everybody believes for how the clouds form on Jupiter and Saturn. And Saturn has the pink ammonium hydrosulfide clouds. It's just they're masked, they're hidden. And you know, Jupiter has white water clouds like what you would see on Earth, but you can't see them because the ammonium hydrosulfide coats all of Jupiter just like the ammonia clouds do on Saturn. So anyway, right about here, the temperature would be about minus 100. If we continued to about 20 atmospheres, which is as far down as the Galileo probe got, then it would be above 0 degrees Fahrenheit. Now, eventually, it'll go insane. It'll go 100 atmospheres, and then 1,000 atmospheres, and then 10,000 atmospheres, and then the temperature will go, 1,000, 2,000, 10,000 degrees. So, in real life, nothing would be left of this probe. But it looks like the probe is going to manage to slow its descent and stop, which is not realistic, but let's just pretend it deployed a balloon at this point, right? I like that idea, right? We didn't know anything about the balloon or the balloon. We unpacked it and it said, "I'm too far from Saturn," and I'm like, I didn't know that we had to do that. So guess what? Now we're finding out that it's actually a balloon. So we'll be able to get some daytime pictures in about 6 hours. Leveling off at 7.5 atmospheres. But yeah, if it were a probe, it would just heat up and completely disintegrate, melt, and then evaporate. Oh my gosh, there's a lot of air out there. Some very high winds, too. Very thick atmosphere. Okay, there we go. It's floating. Transponder on, collecting and sending data. I don't know what kind of data it sends. End of landing sequence. Okay, so we'll come back to that in a day, but we have an orbit to fix. So let's address that. Okay, here we are. So I'm going to delete the actually 3 numbers from that maneuver table. The extra maneuvers that we're doing now will all count as that same maneuver, since it's the same thing, it's just we're going around for a second pass. So yes, we want prograde, and we need to raise the orbit up to about 5,000 meters. That will take us out of the dangerous atmospheric zone, and we'll swing down through the rings exactly where we were last time. So we'll go ahead and do that now. All we got to do is raise the periapsis altitude to 5,000 kilometers, which is right here on the left MFD. $3,000, 4,000, 5,000. Okay, so now we're not going to go back into the atmosphere of Saturn, but we do still have to fix the orbit. So we're going to swing down to the bottom, go through the rings a second time, fix the orbit at that point, and then we'll head back up to the top, fix our inclination, and then align ourselves with a synchronization orbit to Enceladus. About to pass through the C ring again. Very nice. Okay, we'll hold here for a little bit while I calculate exactly what it's going to take to do this burn. Okay, so we're going to go to the Homan again, and I know it's Vis Viva. We got our mass of Saturn entered. Our let's get our altitude in. So we're going to be 62,720 kilometers. And our semi-major axis is 176.6 megameters. So our velocity is going to be 3,100 or 31,529 meters per second. So I said that I wanted this orbit to have a semi-major axis of 100. I'm going to have to look at this a little bit. We need to add 2,500 kilometers to this. So that's going to be 62,466. I got one too many zeros. Okay, 1.5 times 10 to the 8th. So I'm going to get the first number written down, 31,529, and now it's going to change to 1.5 e to the 8, 30,919, 610 meters per second. And now if I just do some quick math here, 610 divided by 22 means it's going to be like a 30-second burn. Let's go back to our maneuver timing. There it is. So we want 610, ship initial mass. Now it's 32,307. Tank capacity doesn't change, ISP doesn't change, engine force doesn't change. So yeah, 16 seconds. That's when we do the burn. Alright, now we'll just fast forward to when to do that in orbiter. Okay, so I'm a lot smarter this time. I actually targeted Enceladus so that I'm not picking some arbitrary point. I'm burning until our orbit matches that of Enceladus. So, let's see, we're about 10 seconds away from the burn. All I can say is that I made an action item to separate the probe so it doesn't enter at the same speed as a critical maneuver. Okay. 2, 1, 0, -1, -2. Okay, that is it. Main engine cutoff, and now we can finally be released from this burn. 30,990. Our final mass is now 32,252.65 kilograms. Our mass going into the next burn will be 3,275.0 meters per second. And now we are up to 6,476 meters per second. Which, if I do the math, 6,475 divided by 4382, that's an overburn of nearly 50%. That's very bad. So that's why I made an action item. Don't try to mess with a probe when you're doing your one of your most critical burns. Let's see what the damage is. That margin is looking really small. It's smaller than it's ever been. We need to be really careful in the next couple burns. And I really hope that these next three, these sink and ring avoidance, the plane change, and orbit insertion are good, because if they're not, we could be going home early. So the next goal is to wait until we get to the nodal passage, and we'll get rid of the rest of the relative inclination there. So let's do aligned planes. We're at 9.61 degrees from Enceladus. This is going to take approximately 167. Okay, fair enough. So we'll come back about a minute before that burn. Alright, so we're about 2 minutes from the burn, but I wanted to start back early because, check it out, we're shooting the Cassini division right here, as I had planned. This is where the Cassini-Huygens probe had gone through the rings. So we went through the C ring, now we're going through the Cassini division. So now we're at an ascending node, we need to lower, so we're going to go down. Alright, plugging in the numbers, 3275.0, and then the mass before the burn, 32,252.5 kilograms, and our orbital velocity, 19,490 meters per second. You're ready for the burn now? 85. There it is. Point 6, point 5, point 4, point 3, point 2, point 1, and not bad. Main engine cutoff, 0.02. Okay, current mass of the ship. Or sorry, I wanted speed first. Uh, 19,120. Now the current mass of the ship. 32,013.615. Use 2,722 of 2,214. So, again, we're showing an overburn. I don't like this. Of 23%. Man. Current fuel on board, 3,036.1 kilograms. I don't like where this is trending. Alright, let me see what the current margin is. We started with... 5120, 5366. We started with a margin of 246 kilograms. Our margin right now is 266 kilograms. Okay. We still have 5%. Fair enough. Alright, so now it's time to start getting synced up to Enceladus. So now I want to go to sync orbit, target Enceladus, and I want ship apoapsis. And let me do some math here, and then I'll explain to you how this works. Okay, so here's how I figured this out, right? I know that the ship is ahead by 14,160 seconds, but we actually want Enceladus to be ahead, so that's a big problem. Enceladus has a period of about 120,000 seconds, so I subtract to get the difference behind an entire orbit that we are trying to sync up with Enceladus, and I'm deciding to do a 2/3 law. So we'll go around Saturn 3 times, Enceladus will go around Saturn twice. That will give us a new orbital period of 69,485 seconds, and we target a semi-major axis of 1.67 times 10 to the 8th meters. So that's going to be 167 megameters. All right, we're back. Sorry to spring this on you guys, but I just realized that this is a ring avoidance too, and that was a very big problem. So I had to change the orbit to a 7/8 because we were going to go into the A ring, and that is very bad. So we're going to need to go around 8 times, Enceladus will go around 7 times, and then we'll sync up. So I'm now targeting a new apoapsis altitude of, a new semi-major axis of approximately 200 megameters, with a burn of 3,624 meters per second, exactly twice as large, beginning at 96 seconds from apoapsis transit. So we are going at about 30 seconds. Now, thank goodness, this is actually smaller than the number that I had for this burn. So we're, fingers crossed, going to hopefully gain back some room that we lost for error. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2. Okay, I was able to find a better orbit to go into. This one uses a 4/5. So Enceladus goes around 4 times, we go around 5 times. That puts us at 185. So this should work. We should be able to put the numbers in now. We're at 11,250. Empty mass of 31,771.1. And a new start mass of 2,794 kilograms starting at the next burn. And let's see where we are now. Yeah, we definitely gained back some ground. I'm glad to see that. But that's going to depend on how hard the arrival at Enceladus is. So we're going to go ahead and save, and we're going to be going around Saturn quite a few times. We're now safe from the rings. We're going to be above the A ring. We just need to make sure that we don't get too close to any of the satellites. And here we go, around 5 times, and we'll probably need to adjust it one more time at least before we're through with it. In the meantime, let's take a look at the probe and see if it's daytime there now. Oh, oops, a little bit of issues here. But there we go. That's what I was going for. So you can now see the ammonia cloud deck up above and the ammonium hydrosulfide cloud below us, with just a few graphical glitches. So There is the Saturnian atmosphere as it looks to the probe right now. Purple horizons, like I said. Okay, so we need to update this one more time, so I'm going to knock out the numbers that I originally had here. We're going to adjust this just one more time. So we need to turn prograde, and we need to increase our altitude so that there's actually an encounter here. And the DT min is a little bit off now. There we go. That's a little bit better. So hopefully we won't have to adjust that again. 31,751.612. So now we're up to 3,009. Still 1,300 kilograms less. And exactly 70,000 pounds. How about that? Mass lift 2,777.5 kilograms. Alright, now we'll go around a couple more times. Yeah, we are going to have to adjust it one more time. So, let's see. We are going to end up here at a shorter time than Enceladus was, which means we need to increase just a little bit more thrust here. And this should be the encounter orbit. There we go. Alright, so we now get $31,726.344 and 2,757.4. That brings us up to 3,300. Hopefully that will be it. Okay, now we're at the periapsis. There should be just over half an orbit left, so now we can actually go back into transects, and then what we're going to do is we're going to select planet Moon, and we're going to go with Enceladus. Right there. Okay, 1 minute out from this burn. This will be a full outward burn to adjust for the timing discrepancy. Alright, 5, 4, 3, 2, 1, burn. Okay, that should be it. Turn the maneuver mode off. And we have, looks like a good encounter. Let's get the numbers again. 31,703.67. We gotta get the numbers, otherwise we could seriously not be able to get back to the Earth. 2735.2, 3563. Still less than by 800 meters per second. That's good. Alright, next is the Enceladus orbit insertion. This is ridiculous. It wants another course adjustment. Alright, maneuver mode off. Now let's see how long you stay showing capture. So there it is, the snowball Enceladus. We're starting to get really close to it now. Now what I need to do is a inclination adjustment. Remember, because I said that we're targeting a specific location on Enceladus. So if we go to the map, we don't want ground track, we want orbit plane. And not Daphnis, we want Enceladus. Alright, at this point we need to adjust the inclination.
Translation.
Okay, let's leave that, and we'll keep drifting towards Enceladus. We'll probably have to adjust that again. Maybe not. It's looking pretty good. Alright, here comes Enceladus. So the next thing that I need to do is calculate my... Well, we already know what... Yeah, circular delta. 1,610 meters per second. So all I need now is just the maneuver time. I need to know how much time it's going to take to slow up. So if I go to my maneuver timing calculator, okay, delta V is going to be 1610. Ship initial mass is going to be 31,696. Tank capacity doesn't change, ISP doesn't change. Okay, so it's 42 seconds. So 42 seconds from the periapsis at Enceladus is when we begin the burn. Now if I go back, let's get our final numbers. I really think that at this point it's not going to change. So we're at 31,695.669 and 2,730.5 kilograms. So we've used 3656 and I budgeted 4303. So assuming that's the end, and I don't see how it could go crazy at this point because of how close we are to Enceladus, we should gain back on this one. Alright, let's continue the approach to Enceladus. And I think that's the crack that I wanted. Yes, that's it right there. We're going to be in a perfect orbit for this. Perfect. Absolutely perfect. Now this is really weird, right? Look at how close we are to Enceladus, and yet Saturn is 97% of the gravity. It's kind of really weird, but Saturn's gravity kind of cancels out because Enceladus is going around Saturn so much. So we actually have to select it here, and we have to manually update the HUD. And we want to keep an eye on that time because we're going to move fast. See, we're already 3 minutes from periapsis, and we have to burn at minus 42 seconds. The
Rotation.
the autopilot will not work because it's going to orient us to Saturn because it thinks that Saturn is the primary body, and it is, but we need to target Enceladus if we're going to stop and stay here. You see how fast we're moving? Burn's going to begin in about a minute. And it has to be really precise. If it's not precise, you can kiss Enceladus goodbye. So we got Saturn on the left, Enceladus on the right. Okay, let's get the before numbers really quick before I forget about it. 31,695.557 and 1742 are the starting numbers, and 2730.5. Yes, we're correct. Okay. 50 seconds to the burn. Actually, 40 seconds to the burn. And Enceladus is tiny, so what that means, it's going to be like eccentricity. Look, it's 170. It's going to be like 170, then 100, and then all of a sudden it's like capture. Okay, we're circular now. All right, minus 42. 20 seconds to go. 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. See, only 10% of the gravity is Enceladus at this point. When the orbit starts to move, it's going to really snap. Eccentricity is now 50, 40, and this is what I was talking about. We're really in a line orbit. Okay, now we're starting to go hyperbolic. I can see it moving. Almost there. Eccentricity is now down to 20. All right, here we go. 6, 5, 4, 3, 2, 1. And to be careful here, capture and main engine cut off. See how quick that is? That's it. We're done. Distance, we're in a 24 by 25. The orbit's good. Well, I feel good about that now. That went pretty well. V2, 133. Huge velocity change. Final mass, 2,591.4 kilograms. Actually, wait, no, this is the ship mass. 3,100 or 31,556.49. And what's left in the tank, 2,591.4 kilograms. All right, let's take a look at the graph. Looks good. We just gained back a lot, and we have plenty of fuel remaining in reserve. We are go for Enceladus landing. So at this point, all I need to do is monitor my map here and know when we get close. Let's see if this will display our ground track now. It might not, because the gravity is all wonky. Yeah, it's not going to. So we're pretty close to where we want to be. I think I said 47 south, 79 east. Unfortunately, there's no way to make an X on the map here, which is what I really want to do. And I don't think that there's no features here. So it's just a featureless map that shows where we are. But anyway, Enceladus, guys, we're almost here. Almost here to our first destination, that is. You got to be really careful when you're orbiting a small moon like Enceladus around Saturn, because Saturn will perturb your orbit. You need to really know what it's doing. Keep an eye on it, because one minute you could be up at 25 kilometers, and then Saturn's going to bring you down to 15, and then all of a sudden, oh no, I didn't expect that to happen. So we're back up at 25 now. Alright, we're looking for our nice blue crack to show up here. And for that we need to be in the southern hemisphere. Remember, we only have 131 meters per second. That's our orbital speed, which means that we can actually stop on site, and that's what I'm going to do. Okay, I think right about there. It's kind of hard to see because it's so dark, but I'm pretty sure it's blue. So that's going to be our landing location. So let's turn retrograde. We're going to start the landing sequence now. Alright, first numbers 2591.4 on the initial mass. And then for the entire ship, it's going to be 31,556.25 kilograms. V1 is going to be 134, V2 is going to be 0. That is absolutely known. And all we got to do now is perform the landing. Whoops. See what I mean? You do the retrograde autopilot and it's going to make me retrograde Saturn, not retrograde Enceladus. Okay, then remember we have our instructions here. The much better fuel landing economy. It says we do our deorbit burn. Watch how fast this disappears. Boom! Gone. There goes all of our speed. Just like that. We're going to go into surface HUD mode now. When we get within 20 kilometers, we're going to go full retrograde. And we're going to select the attitude hold autopilot. Not attitude. There it is, the descent hold. We'll hold negative 2.5. So at this point, we're going to do our VLAND checklist. RCS mode is desired. We'll use rotation. APU on. Gear down.
Gear down. Gear down and locked.
Okay. Hover doors open, retro doors open. Okay, nav lights on, beacon and strobe on. APU is desired. We'll turn it off for now. Alright, so at this point I need to get our landing velocity. So at 72 meters per second, it'll take us 3 seconds to stop. But we can use 1/5 of the hover force, which is going to take 15 seconds to stop. Okay, so it's going to be 0.5 times 1/5 of our hover acceleration force, which is going to be 2.7 times t squared, which is 28 squared, means we want to start slowing down when we're 1 kilometer above the surface. So at retrograde and at 15 kilometers, we're going to kill off all of our velocity. Let's see, our touchdown location looks pretty good. Looks like we might actually be coming down on a snowbank, which is probably what we want. Okay, we're now at 15 kilometers, so we're going to put attitude hold on. And we're going to get rid of all of our remaining horizontal velocity. Go back to orbit, and we should be pretty much straight down with no velocity now. So our vertical speed is 38, our ground speed 38.4, which means we have a rolling ground speed of about 0.4 meters per second. That should be good for the time being. Just monitor the attitude hold autopilot for the time being. I also just want to give the hover thrust just a little kick to verify it's going to light, because we don't want a nasty surprise. Okay, that's worked. So we know the hover thrust is working. Alright, where's the sun at? So our shadow will be coming over from back there. Okay, 9 kilometers to go. When we get down to about 1 kilometer, we're going to use about 1/5 of hover thrust. So we're going to set the hover bar to between the E and the R.
3,000.
3 kilometers to go.
$2,000.
Okay, 2 kilometers to go. 1 until we activate the engine.
You are cleared to land.
Okay, 3, 200 meters, 100 meters. Okay, engine activated.
1,000. 900. 800. 700. 600. 500. 400. 300.
'Alright, here it comes.
100. 75. 50.
Alright, we're at 5,
40.
4,
30.
3, 2
20.
meters per second.
15. 10. 7. 5. 3.
Alright, slowing to
2.
contact speed.
1. Touchdown. Lift off. Touchdown. Touchdown.
Okay, we've settled.
Touchdown.
Disabling autopilot.
Touchdown.
Hitting the brakes.
Touchdown. Lift. Touchdown.
Please
touchdown.
stop.
Touchdown. 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 Lift. Touchdown.
Alright, we have a little bit of gravitational
Lift. Touchdown.
issues here. Just give it a
Touchdown.
couple
Lift.
seconds.
Touchdown.
We
Wheel
should-
stop.
Okay, we've settled. Alright, we are on the ground on Enceladus. So at this point we need to safe the ship. So we don't want to shut down. What we're going to do is secure configuration. So we're going to turn the HUDs off, tertiary, secondary, primary HUDs off. Radiator open. It is open. Nav beacon and strobe lights off. RCS mode off.
Rotation off.
Okay, hover and retro doors check closed. They are not. We're going to close them now. We're also going to open the nose cone and the inner door. Okay, here we are. Day 1461 in 16 hours. We're on the ground of Enceladus. So I'm going to check my situation. Alright, so we have completed touchdown. Our current mass is 31,535.195 kilograms. And our next burn will start with 2,573.6 kilograms left in the tank. And let's see what our situation is. So we used... I have to drag this down. So we've used 244. We planned 232. That's fine. We're still flatlining. And don't forget, too, that our previous burn, the Enceladus arrival burn, and the Enceladus plane change burn, both ended up using less fuel than we anticipated. So our margins are slightly grown. And we are go for stay on the surface. So I think in Apollo they had a checklist called stay or no stay, and we've done it. We're stay, and looks like we've got just a little bit of light left. So let's get the bay open. I should have done that too. And since it's dark, we're going to turn the lights back on again. Go to payload camera, and I want bay doors open. Okay, highlight the bay door, or the bay 2, deploy.
Payload deployed.
And magically, there it is on the surface. Of course, only 3 of the 4 payloads. RIP, atmospheric suicide probe. All right,
APU offline.
shoot. Everybody get into the cargo thing. So now, everybody, all of us are in the airlock now. We're going to depressurize.
Airlock depressurizing.
And that reminds me, we need to check our oxygen levels. So we're at 49.94. We're at Saturn. That's the halfway point, and we've only used 23% of the oxygen. We're in good
Airlock
shape.
pressure 0 psi.
Okay, outer door open. Okay, APU offline. And let me confirm that the ship is in final configuration the way I want it. Yep. Lights on for safety. Radiator deployed. Everything is the way I want it. Okay, everybody off.
Egress successful. Egress successful. Egress successful. Egress successful.
Okay, that's it. Everybody's off. Here I am walking around Enceladus. Unfortunately, there's a little bit of gravitational issues on such a small planet like Enceladus. So we're having a few issues walking around. So I'm using forward translation and it's not moving me at all. So unfortunately, it looks like the manned mobility units are going to have issues on Enceladus. There's 3 cargoes. There were 3 cargoes in here. Now there's 2. Okay, now there's 1. Where's this cargo going? Oh, there they are. They're just not selectable vessels. Why'd it go to Saturn? This makes no sense. Alright, can I set the flag up, please?
Unpacking cargo.
Right. We got our first cargo unpacked, the flag. Okay, now I'm upside down. Now I'm facing the other way. Okay, guys, here's the deal. I had to fork the video at this point because I tried to get out of the ship using the people, and there have been so many gravity glitches that I can't set up the base. Furthermore, when I tried to exit, or I tried to do it manually via the scenario editor, moving things around, I found that things were just magically teleporting to Saturn, which I've never, ever, ever seen before. And that's not possible other than through, magic-y scenario stuff. So I exited and found out that my simulation refused to load. So now I had to create another one, and that loaded from the Enceladus orbit. And now we have new values for the landing because I had to redo it. But we're in approximately the same location we were in. We're at 47 west, 56 south. 47 west and 56 south compares very well with 45 west and 56 south. So we're very close to where we were. But I don't know what happened, why it decided to go crazy. Alright, so we're now 31,535.6. It's only a difference of 0.4 kilograms. That's the only difference. 2574.4. Okay, so yeah, it doesn't really change anything. It's a fraction of a kilogram, but hey, we track it, right? So we're going to leave it here. Hopefully the sim doesn't crash. The good news is we're going to go to Titan next, and there the gravity is much stronger. We should be able to set up a base. When I say much stronger, I mean I'm pretty sure that Titan is like almost 1,000 times as massive as Enceladus. I can actually look it up right now. We do celestial body, Enceladus is 7 times 10 to the 19th kilograms. Titan is 1 times 10 to the 23rd kilograms. So yeah, it's more than 1,000 times as massive, and it's like 6 times further away from Saturn. Which means the gravitational authority is going to be like a factor of 36,000 times stronger than Enceladus. So I don't anticipate there being problems when we get to Titan. So we'll go ahead and leave it here. I'm going to quick save one more time. Welcome to Enceladus. I've been Dr. Aeronautics, and I will see you guys next time where we moon hop to Titan and then Iapetus. Bye-bye.